Alright, so for this one we're actually going to combine 9 and 10 into one video because they relate to one another. This gives us a good chance to apply everything that we've done in this unit and apply it to a real-world problem. So it says that we run a bottling plant, and with our bottling plant we make two different Cokes. We make regular Coke and we make a vanilla Coke. And what we're trying to figure out in this problem is that does it make more sense to just do all regular, all vanilla, or maybe it makes more sense to do a little bit of both? How do we make that decision? Well, it's going to be based upon our time constraints, and constraint is just a fancy word for limitation. Because we only have so many hours that we can run these machines, and we have only so many hours that we can pay people to work in our factory or our facility here. So we don't have an infinite number of amount of time, so we have to kind of make a decision based upon that. So let's look at the first part. So there's kind of really two pieces. How many hours we can run the machines, and then how many hours we can pay people. So let's start with just the machine hours. So we'll say machine, and for regular cola, and we don't know how many regulars we're going to make, so we'll call that X. And we don't know how many vanilla Coke we're going to make, so we'll just call that Y. But what it says is that if we're doing the machine, it's 3 hours for each regular cola plus 4 hours for each vanilla. 2 hours for each vanilla. And then the most that we can run the machines, whether we do all of one or we do a mix, but the most that we can run the machines is 54. Now you see this is a less than or equal to, so that means that we can run it up to 54, but maybe we run it for less, right? Maybe we run it for 53 hours or 52, so it just kind of depends. And then the other constraint or limitation is how many hours we can pay people here. So it says that on the labor is 4 hours for each case of Coke, and 3 hours for each case of vanilla, and then that has to be less than or equal to 75. So we can't pay people for more than 75 hours. Maybe that's all we have in the budget. So these are going to be our two constraints, and what we're going to do from here, I'm just going to move this over a little bit. What we're going to do from here is that we're then going to say, well, let's talk about the machine hours. What if we just ran the machine and let's say we just did all regular Coke? So we're saying that we're not doing any vanilla Coke. What if we just did all regular? So if we did all regular, we want to see how many cases could I make in that 55 hours if I just run the machine for regular. Well, if I run the machine just for regular, that means that I'm not doing any vanilla at all. So it's almost like that 2y just disappears, and that would be less than or equal to 54. Well, if I divide both sides by 3, quick check in the calculator, 54 divided by 3 gives us 18. So what that says is that if at 3 hours per case, I got 54 hours to run the machines, I can make 18 cases of regular Coke. Now, what we want to say is that kind of the opposite is, well, what if we just did all vanilla? How many cases could we make? Well, if we do all vanilla, that means we're not interested in doing any regular, so what we would have is 2y less than or equal to 54. Let's divide both sides by 2. And again, quick check in the calculator, 54 divided by 2 gives us 27. So what that means is that of the 54 hours that we can run the machines, if we did go with all vanilla, we could make 27 cases of Coke, or vanilla Coke, I should say. Alright, so just to get kind of a visual of that, let's go up to the graph, and what we're going to do is that we're going to graph that possibility. So, and just to kind of keep things straight here is that, again, remember the X is going to represent regular, and then the Y-axis is going to represent vanilla. So the Y is going to represent vanilla. So I can make 18 cases of regular if I went all regular. This is counting by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18. And then if I went all vanilla, I could make 27. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. One more would be 27, right? So here's one possibility if I'm just looking at my machine hours. Maybe I do 18 cases of regular, no vanilla, or maybe I do no regular and I do 27 vanilla. So again, I'm just before we get to the profit and like which one do we make more money doing, I have to first figure out just how much can I make. What's my potential capacity to make here, because again I have limitations, a time constraint. So I got to figure out how much I can make before I figure out what's going to make me the most money. Alright, but we can't just worry about machine hours because we also have man hours that we have to worry about. So I might say, oh yeah, I'm going to run the machines to make 27 cases of Coke, but I may not have enough time to pay people to make 27 cases of Coke. So that's what I need to do, is double check over here. So kind of same thing, we're going to make an assumption. What if we did all regular? Again, this is our labor here. So if we're paying people to do all regular, that means that we're not doing any vanilla. So that's going to end up being 4x less than or equal to 75. And if we divide both sides by 4, we get x is less than or equal to, and let's check this in the calculator. Probably not going to divide evenly here. 75 divided by 4, and I get 18.75. Well, so the thing is though, is I can't make 18.75 cases, just like I can't hire 18.75 people. We need a whole number here. Now, you're probably looking at 18.75 and say, well, let's just round that up to 19. Thing is though, if I say that I'm going to take 19 cases of vanilla times the 4 hours that it takes to make it, that's going to take me 76 man hours to do that. But I only have 75. So what I can't do is I can't make 19 cases because I don't have time. It's only up to 75. So let me go down to 18 and let's see if I got enough time to do that. Yeah, so we get 72. So that comes in under our number. So what we're going to say here is that that we've got 18 cases that we can make. Now let's say all vanilla. So if I do all vanilla, let's see how many cases I can make given how long I can pay people to work it. So divide by 3, so we get y less than or equal to 25. So I can make 25. I've got time to make 25 cases if I decide to go all vanilla. So let's do the same thing. Let's graph it. This was 27, so 26, 25. And then on the x, actually ends up being the same number, ends up being 18. And, you know, it was 18.75. Now, what we're going to find is that, again, as we said, well, we can't make 18.75, but we just want to see on the graph what that would look like. And it's not going to be perfect, and I know this graph is kind of tiny and kind of hard to read. Alright, so again, we've got 3 possibilities here. So our all regular number, if I take into consideration how many hours I've got to run the machines and how many hours I've got to pay people, if I look at the possibility there, it looks like I can do, if I want to do all regular, is that I can do all regular, so I could do 18 and then 0 vanilla. And how many all vanilla can I run? Well, it has to be the lesser of these two, because I might have enough, as we said earlier, I might not have enough time to run the machine, but then maybe I don't have enough time to pay people, right? So am I going to pick 27 or am I going to pick 25? Well, I've got 27. I've got enough machine hours to do 27 of vanilla. But if we look at this one over here, my man hours, 3 times 27 is 81. So that puts me over. See, I've only got 75. So I can't do 27, so I have to go with the lesser of the two, which would be 25. So my all vanilla number is going to be 0 regular and then 25 vanilla. Now I've got a third possibility, which is maybe I make a little bit of both. And you know, where do these two lines cross? That represents where I could make maybe a little bit of both. Now my graph, it's a really tiny graph, it's hard to read. I'm not sure actually where those two lines cross. So what I'm going to do to actually find out that number for sure is I'm going to take the two that I have and I'm going to use elimination, right? Because when you solve by substitution or elimination, what you're finding is where the two lines intersect or where they cross. So I'm going to do that very thing to figure out where those two lines cross. So I'm just going to take my two inequalities here, 3x plus 2y less than or equal to 54, and then I've got 4x plus 3y less than or equal to 75. And what I want to do here is I just want to eliminate either the x or y, it doesn't matter which one, so we just pick one. I don't know, let's say that I wanted to eliminate the x's, for instance. If I wanted to eliminate the x's, there's nothing I can multiply 3 by to make it a 4. Oh, but so then I got to pick a number they both go into. Well, 3 and 4 both go into 12. So if I wanted this to be a 12x, I have to then go back and say, well, what would I need to multiply to make that happen? Well, 3 times 4 is what gives me 12. But then the thing is, I can't just change 1 without changing everything else. So I'd have to multiply everything by 4. And this is very similar, by the way, or exactly the same thing that we did in problem number 8, is having to multiply both so that we could get something to eliminate. So 4 times 2y would give me 8y, and then 54 times 4. Quick check here, 54 times 4, and that's going to give us 216. And then for the second one, if this is a 12x, I've then got to say, well, what would this be? To cancel with a positive 12, this would need to be a negative 12. Well, I then got to figure out, well, how can I make that happen? What times 4x would give me the negative 12? Well, this would need to be a negative 3. Same thing, I can't just multiply 1, I've got to multiply all of them. So if I distribute across there, get a negative 9y, and then 75 times 3 would be a negative 225. Let's double check that. 75 times 3, negative 225. And then now I've got a system I can solve. So the x's cancel. Looks like I've got a negative 1y. And then actually what happened there, since we multiplied by the negative, that would have became a greater than or equal to. And then difference there would be a negative 9. Divide by negative 1, that actually switches back around, and so we end up with y less than or equal to 9. So what that means is that for the y value, and again my graph isn't accurate, or as accurate, 2, 4, 6, 8, so there's 9. Well, it's pretty close, right? Now we just want to figure out what that is on the x. Maybe a guess, 2, 4, 6, 8, 10, 12? That looks like that might be a 12 on the x, but let's do the math just to make sure. So I would take one of the equations, doesn't matter which one I pick. I don't know, I'm going to go with the first one there. So I'm going to take 3x plus 2y less than or equal to 54, and then I'm going to take what y is equal to, what I found out that it is, and I'm going to substitute it right there. So I've got 3x plus 2 times 9. Well, 2 times 9 would give you 18. And then I'm going to take 18 away from both sides. So I got 3x is less than or equal to, and then 54 minus 18 is going to give me 36. And then if I divide both sides by 3, I get x is less than or equal to 12. Oh, okay, so that actually does check out. I thought that it looked like it was going to be at 12 on the x, and it was. So our third possibility is that we've got time, both machine hours and man hours, to make 12 regular and 9 vanilla. So here's our three possibilities. We do 18 regular, 0 vanilla. We do 0 regular, 25 vanilla. Or we do 12 regular and 9 vanilla. That's what we have time for, right? Now, how do we pick which one out of the three? Well, we have to look at what's going to make us the most amount of money. So if we look back at the problem, it says that we make $20 for each case of regular and 25 for each case of vanilla. So this is where I'm going to go down to number 10, and this is how I'm going to show my work and what decision we make with what we end up making. Alright, so I'm just going to draw a little bit of a table here. And again, we had regular, and then we had vanilla. Right, so here's my point. And then the profit on it, it said that we made $20 for each regular. So 20 for each regular. Right, so this would be X for regular. Plus 25 for each vanilla. That's our Y. And then what we want that to be is that, well, that's going to equal our profit. And then what we want to see is that, well, which one is going to give us the most amount of profit? Well, so remember our three possibilities. We said that maybe we do 18 regular and then 0 vanilla. We also said maybe we do 0 regular and 25 vanilla. Or there was our combination, which is where we said, well, maybe we do a little bit of both. Maybe we do 12 regular and 9 vanilla. And what I'm looking for is I'm just looking for which one's going to make me the most money. So all we're going to do is we're just going to plug in these numbers to see which one would be the most profitable. So just filling this out, $20 for regular, 25 for vanilla, and then let's see what gives us the most money. So I'm going to say here 18, this is if I do 0, this is if I do 12. And for vanilla, this is if I do 0, if I do 25, and if I do 9. Alright, well, let's just throw that in the calculator and see what we end up getting the most of here. 20 times 18. Pull the calculator over here out of the way. So 20 times 18. And that ends up giving us 360. If we did 25 times 25, that gives us 625. Okay, so that gives us a lot more. And then what about the mix, right? So if we did 20 times 12, 20 times 12 would give us 240. And then if we did 25 times 9, that would give us 225. So if we added, so this was 240 and this was 225. So if we added those two things together, so let's say 240 plus 225, we get 465. Well, so it looks like which one's the most profitable for us would be doing all vanilla. Right, because we end up actually making the most profit out of that. We make 625, which is more than 465 and 360. So what we would do is make, we'll just do one sentence here. The most profit will be made if we, not when, if we make 25 case, well, we could say make 25 cases of vanilla and no regular. Alright, so I know that was kind of a long problem. There was a lot of different little pieces to it. But if you take your time through it, hopefully That makes sense. Also, what hopefully should make sense is that from the very beginning you thought maybe vanilla made the most sense because vanilla is less machine hours and it's also less man hours. So you might have thought right away like, oh, this makes more sense to make vanilla, and we actually make more money off vanilla. So you might have made that prediction in the beginning, and if you did, you were correct, but we just wanted to prove this. Alright, so go ahead and stop now, and let's try 9 and 10 on the right side.